Light moves with a rule no other thing in the universe obeys. It refuses to go any faster. What if I told you that this is not just a rule written by Einstein? What if I told you that the deeper reason comes from a mind so brilliant that few teachers ever explain his idea in a way that opens your eyes to the true nature of reality? Light travels fast, but its speed is not random. It is not just a number. There is a deep reason behind it, and that reason will change how you think about motion, time, and the universe itself. In this video, you are going to learn why light has a limit. You will discover the hidden logic behind the speed of light, a limit that governs not only light but everything in the universe. You will hear the voice of a genius whose ideas are rarely taught in school but hold the key to this mystery. We will explore how light can act both like a wave and like a particle, and how this dual nature is connected to its fixed speed. You will see why the established explanation, the one most textbooks give you, is only part of the story. Then we will dive into a different perspective, one that comes from a physicist who saw the universe from a new angle, a man whose way of thinking reveals why light's speed is not just a boundary but a consequence of something much more profound. You will learn how paths cancel and reinforce, how waves add up, and how the only speed that survives this incredible balancing act is the speed of light. By the end of this video, your understanding of light will no longer be the simple formula C equals 299,792,458 meters per second. Instead, you will see that this number emerges from a cosmic principle, a rule sewn into the very fabric of reality. You will find out why nothing can outrun light, not even the fastest particle. You will see how space and time fold together to demand this limit, and how the genius explanation behind it has been hidden from most classrooms. This is not just physics. This is the story of how the universe chooses a speed, and why that choice shapes everything we know about motion, energy, and reality. Stay with us until the end, because we will close with a revelation that connects this limit to the way all things interact. And this will make you see familiar ideas in a completely new light. This is a journey into a truth that feels almost philosophical, a truth that shakes the foundation of what you think you know. And through it all, we will keep the explanation simple and grounded, so that every step makes sense and every idea feels clear. You will not just hear facts. You will begin to feel the logic behind them. You will start to see the universe in a way that few people ever do. So, if you are ready to see behind the curtain of one of nature's deepest secrets, stay tuned, because the explanation you will hear in this video is powerful, surprising, and different from what most teachers will ever tell you. Welcome to our channel. Make sure you subscribe and turn on notifications so that you never miss the next fact that changes the way you understand the world. Let's begin. Light is one of the strangest and most familiar things in the universe. You see it every day, yet most people never stop to think about what it really is. At its core, light is energy that travels in waves. These waves move through space, carrying information and energy from one place to another. But light is also a particle. These particles are called photons. When you flip a light switch, countless photons begin racing outwards. They behave like tiny bullets and like ripples on a pond at the same time. This dual nature baffled scientists for centuries. It seemed impossible that something could be both a wave and a particle. But this is exactly how light behaves, and this behavior is deeply connected to why it moves the way it does. What makes light even more mysterious is its speed. Whether it is coming from a lamp, a distant star, or a laser pointer, in a vacuum, light always travels at the same speed. That speed is known to physicists as c. It is about 299,792 kilometers per second. No matter how you measure it, that number never changes when light is in empty space. Light does not slow down or speed up on its own in that environment. It will always carry on at that exact pace, unless it interacts with something else, like air, water, or glass. When we think about speed limits in everyday life, we think about rules put in place to keep things safe. Cars have speed limits on highways and in cities. Those limits are written on signs and enforced by police. Drivers can go faster or slower if they choose, but they are expected to obey the posted limit. We understand speed limits as human rules, boundaries set to protect people and keep order. But the speed limit for light is nothing like a speed limit you see on a road sign. Light does not obey its speed as a choice. The limit is not a law that someone wrote down. It is built into the very way the universe works. There are no signs in space telling light how fast to go. That speed limit arises naturally from the laws of physics themselves. It is a boundary woven into the structure of space and time. Albert Einstein is often the first scientist that people think of when discussing the speed of light. Einstein proposed that the laws of physics should look the same to all observers, no matter how they are moving. From that simple idea, he found that the speed of light must be constant. That means that if you measure the speed of light while standing still, and someone else measures it while riding in a fast rocket ship, both of you will get the same number for the light's speed. That is astonishing, because with almost any other object, speeds add up. If you throw a ball forward while riding a bicycle, the ball appears to go faster than the bicycle. Light does not behave this way. Einstein showed that when you measure light in a vacuum, its speed never changes. What this means is profound. The speed of light does not simply limit how fast light can go. It connects space and time. Space and time are not separate entities. They are part of the same fabric of reality. When you begin to think about moving fast, time itself begins to change. Near the speed of light, distances shrink and time slows down. These effects are not weird artifacts or illusions. They are real, measurable outcomes of the universe's structure. Still, even Einstein's explanation leaves a deeper question. Why does nature behave this way? Why does the universe demand that light moves exactly at this speed and not faster? What is it about the cosmos that forces this limit? To get closer to an answer, we turn to Richard Feynman. Feynman was a physicist who saw the world in a way few others ever did. He had a unique ability to look at a problem from an angle that most people never consider. Feynman did not just think about light as something that moves from one point to another in a straight line. Instead, he imagined that light travels every possible path at once. Yes, every single path it could take. If a photon goes from point A to point B, Feynman asked what would happen if it tried every possible route imaginable. Some of the paths are straight lines. Others are curvy, looping, even wildly twisted. According to his idea, light does not commit to a single path ahead of time. Instead, it explores all possibilities and somehow chooses the result that we observe. This sounds strange, but this way of thinking opens a window into how quantum mechanics truly operates. Feynman turned this concept into what is known as the path integral formulation. In this picture, each possible path contributes to the final outcome, like a wave. Waves can combine, and when they combine, they interfere with each other. Sometimes they add up and make a bigger wave. Other times they cancel each other out. Feynman realized that most of the possible paths light could take end up canceling themselves out. The peaks and troughs of the waves wash over each other until nothing remains. Only a small range of paths reinforce one another and survive this process. The result of all this interference is that the path we observe is the one that light seems to take. A path where the contributions from many possibilities have lined up perfectly. This idea by Feynman explains not just how light travels, but also why its speed is fixed. When you look at the math of these interfering paths, you find that there is only one speed at which all of the surviving contributions line up cleanly to make a real wave that a photon can follow. All other speeds cancel out, just like all the paths that do not reinforce each other vanish. What remains is a situation where light must travel at the speed we call c. Any attempt for light to go faster or slower does not lead to a coherent result. The waves from different paths do not add up in a way that produces a real outcome. They cancel each other. So the universe seems to choose this particular speed through a kind of cosmic selection of possibilities. The outcome is not arbitrary. It is the result of how all potential paths combine. This perspective is not what you typically find in textbooks because most teachers stop at Einstein's equations. They explain the constancy of light speed as a postulate of relativity. They do not often take you inside the deeper quantum reasoning behind it. Once you see this idea, it changes how you think about motion itself. Nothing in the universe can go faster than light, because the only way for information or energy to travel from one point to another is by following the paths that survive this wave interference process. If something tried to go faster, its possible paths would cancel out just like the bad ones do for light. What remains would be nothing. This tells us that the speed limit is not a speed limit in the ordinary sense. It is the only self-consistent option allowed by the rules of quantum mechanics and relativity working together. Because space and time are linked, exceeding light speed would lead to contradictions. Events could end up happening before their causes, and that undermines the basic logic of reality. That is why nothing can outrun light. Not electrons, not rockets, not even information itself. Light speed becomes nature's rule, woven into the fabric of space and time. This rule has dramatic consequences. It means time can stretch and shrink. Objects moving near the speed of light appear shorter in the direction of motion. Clocks moving fast tick slower compared to those at rest. These are not theories or speculative ideas. They have been tested again and again in laboratories and in devices orbiting the Earth. GPS satellites must account for these effects, or their measurements would drift by kilometers every day. The universe insists on this behavior because of the same underlying reason light has a fixed speed. As we dig deeper, light's speed limit is no longer just a number in an equation. It becomes a principle that underlies the way matter, energy, space, and time all connect. In the universe, nothing exists in isolation. Everything interacts through fields and waves. Light itself is an electromagnetic wave. Its behavior reflects the structure of the fields it travels through. The speed at which these waves propagate is fixed by how the electric and magnetic parts of the field influence each other. When Feynman's path thinking is applied to these fields, the same conclusion emerges. Only at the speed that matches the field's structure do the wave contributions survive interference. Other speeds fade away. So this speed limit is not something tacked onto physics. It is a natural outcome of how the universe's waves interact. This way of understanding light also shows that the concept of a single path is not fundamental. In the quantum world, the universe is more like a symphony of possibilities. Each possible history contributes a tiny bit to the final result. Most cancel, a few combine. What we see is the harmony that survives. In that harmony lies the fixed speed of light. That is why light does not slow down or speed up in a vacuum. Space and time conspire to allow only one consistent motion. Light is obeying the deepest rule of nature. It is not choosing speed. It is simply the result of how all possibilities add up. Light's speed limit tells us that the universe is far more interconnected than we might have guessed. This limit is not a boundary set from outside. It is a consequence of the interplay between quantum possibilities and the structure of space and time. When you look at the universe through this lens, you begin to see why physics leads to the strange and beautiful rules that govern reality. Light's limit becomes a doorway into understanding those rules. It shows that the world is not built from separate bits pushing against each other. Instead, it is woven from waves of possibility, adding and canceling, selecting the outcomes that form the reality we experience. In this view, the speed of light is not just about light. It is a reflection of the way the universe itself chooses what is possible. The story of light shows us that even the simplest questions can open doors to truths far beyond what we see. What seems like a mere number, the speed of light, is actually a window into the deep logic of the universe. It tells us how space and time are connected, how the paths of everything are intertwined, and how the universe quietly sets the rules that govern all motion. Understanding this limit is not just about physics, it is about seeing the elegance and intelligence hidden in nature itself. If this journey made you pause, think, or wonder, then show your support by liking this video, sharing it with friends who love to explore the mysteries of the universe, and subscribing to our channel. Stay with us to uncover more ideas that challenge your understanding, reveal hidden truths, and make the incredible story of the universe simple and exciting. Keep watching, because the next discovery is just around the corner.